Welcome back. Algebra 3, we are in lesson 24. I'm going to evaluate some trigonomic functions. We're going to do some sums of some trigonomic functions. So this problem says to evaluate cosine of 60 degrees plus the sine of 45 degrees. So I've already drawn out my reference triangles and I've put in the numbers where I need them, my values. So we're going to add the cosine of 60 and the sine of 45. So first I have to remember sine and cosine, right? So ka, and I don't really need toa, but I kind of feel like I have to say it, it's like part of the thing. All right, so sine of 45 is going to be the opposite, which is 1, and that's going to be over the hypotenuse, which is the square root of 2. And the cosine of 60, you're going to have the opposite, no, it's the adjacent, that's 1, over the hypotenuse, which is 2. So we're going to add those two together. So the cosine of 60 is 1 over 2, plus the sine of 45, which is 1 over the square root of 2. We know we can't add those because they don't have a common denominator, but taking it a step further, we don't like to have radical symbols in the denominator. So I'm going to get rid of that first. Times the square root of 2 times the square root of 2. So that is going to give me 1/2 plus 2 over 2. So I can do that now. I can actually say 1 plus the square root of 2 all over 2. And that would be my answer for that. So you see it's not very difficult. It's exactly what you think it is. You find the sine, the cosine, whatever the trigonomic function is that it wants you to do, and then you just perform that operation. Not so hard. Let's do another one. 24.2. This one says to evaluate, I'm just going to write eval, the tan. Sorry, there's a storm out. Probably hear that. The tan of 30 degrees plus the cosine of 45 degrees. So again, I'm going to draw my reference triangles here. And here is this one. All right, so this is 60 and 30, and this is 90. And this is 1, 2, square root of 3. And this is 45, 45, 90. We know this is an isosceles triangle because these are the same degree of measure. So that means 1 and square root of 2. Okay? So we have our reference triangles back. So again, I'm going to write up here SOHCAHTOA just to remind myself of the whole thing. Roscoe's crying because it's stormy out. He's a big old baby when it comes to storms. Lay down, buddy. It's okay. So the tan of 30. So the tan of 30 degrees, that's going to be the opposite. The opposite is 1 over the adjacent, which is going to be the square root of 3. Plus the cosine of 45 degrees. And the cosine is going to be the adjacent, which is 1, over the hypotenuse, which is the square root of 2. All right, so we have the 1 over the square root of 3 plus 1 over the square root of 2. So we need to get rid of the radicals in both of these denominators. I'm going to multiply this by the square root of 3 over the square root of 3 plus 1 over the square root of 2 times square root of 2 over square root of 2. So that gives me square root of 3 over 3 plus square root of 2 over 2. Now we need to find a common denominator so we can add these together. So we're going to multiply both by the opposite denominator. So that's going to be 2 times the square root of 3 over 6 plus 3 times the square root of 2 over 6. So that means that we have 2 times the square root of 3 plus 3 times the square root of 2 over 6. And that's going to be our final answer. See how easy this is? This is not even hard. Instead of redrawing everything, I think I'm just going to erase and write in the other problem, just so we can keep our reference triangles and I don't have to do that bit all over again every time. So 24.3 says to evaluate, I've got the tan of 45 degrees plus 2 times the tan of 30 degrees. All right, so the tan, that's TOA, T-O-A, so TOA. The tan of 45 degrees is going to be, that is the opposite 1 over the adjacent, so 1 over 1. And then I need the tan of 30 degrees. So the opposite is 1, and the adjacent is square root of 3. All right, so 1 plus 1 over the square root of 3. Again, multiply this times the square root of 3 over the square root of 3 to get rid of this denominator. 1 plus the square root of 3 over 3. So I need to turn this into a value that is got the right denominator. So that's going to be 3 over 3 because that's still 1, right? So my final answer is 3 plus the square root of 3 over 3. All right. Oh, you know, it's not. I am so sorry. I totally forgot. And you guys are probably going, Miss Tracy, you messed up. It's 2 times the tan of 30 degrees. So 2 times the tan of 30 degrees would be 2 over the square root of 3. All right, sorry about that. You know, that is why we have to double check our work. You know, it happens to the best of us. So here we go again. Multiply that times square root of 3 over square root of 3. Get pretty much the same result. I'm going to turn this into 3 over 3 plus 2 times the square root of 3 over 3. That gives us a result of 3 plus 2 times the square root of 3 all over 3. And that is your final answer. Sorry about that. It was a goof. I made a little goof. I apologize. All right, let's do one more like that. Again, I think I'm just going to erase instead of having to redraw the triangles. You see, though, it's really not that difficult. You guys know everything already. We're not learning anything new. You know everything you need to already in order to solve these. So we're going to evaluate the square root of 6 times the sine of 30 plus 1 divided by the square root of 2 times the tan of 60 degrees. All right, so sine is going to be the sine of 30. That's going to be 1 over 2 because it's opposite over hypotenuse. All right, and then the tan of 60 degrees, that's going to be the opposite over the adjacent. So the opposite over the adjacent, that's going to be the square root of 3 over 1. So that's just going to equal the square root of 3. All right, so the square root of 6 times the sine of 30, which is 1/2, plus 1 over the square root of 2 times the square root of 3. All right, so let's look at that. That's going to be square root of 6 over 2 plus square root of 3 over the square root of 2, which we can't have. We've got to get rid of that. So we're going to multiply this times square root of 2 over square root of 2. So that's going to give me square root of 6 over 2 plus square root of 6 over 2. All right, we have that invisible 1 in front of those now that they're the same base. That becomes 2 times the square root of 6 over 2, and 2 divided by 2 is 1, so our answer is just the square root of 6. Easy peasy. You guys can do this without even thinking about it. All right, so let's talk about combining functions. We found that f of x, g of x, and h of x are just other symbols for y. Whenever we do, let me clear this. Whenever we would do, y is equal to whatever, like mx plus b, we learned that they would just give us different names for the function. So if we had multiple lines on a chart, let's say we had y equals 1/2 x plus 4, y equals 2x minus 3, and y equals, 4x plus 7. Let's say we had those 3 lines. Well, instead of all those lines running together, they gave them names because it was understood that y was right there. So they would say f of x, they would say h of x, and then they would say g of x. And then on their little system over here, maybe, this would be line f, and this would be h, and this would be g, just for supposies. But it's just a way of naming the lines so that you could identify which one was which one without having to go into the calculations, right? There's just a way of naming the lines and identifying different functions on the graph. That's really all that is. But it looks specific and it looks kind of complicated. There are other ways that we can use this functional notation. For instance, we could say f of x plus g of x, right? Which could be written the same way as f plus g times x. And that is used to denote the sum of function f and function g. Also, we could have f of x minus g of x, and that would be the same as saying f minus g of x. So we could find the difference of two functions when the g function is subtracted from the f function. All right, we could also write it like this. If you have f of x times g of x, we could write that fg of x. And that's where we would multiply whatever the product of function f is times the product of function g and combine them into one, right? And likewise, we could also do that with division. We could say f of x divided by g of x, which would be f over g times x. So we could write this all of these ways also, and it means exactly the same thing. It means exactly what you think it means. It's just where we have kind of factored out the x to one side, and it's just a way to write it more succinctly, to write it faster, which is one of the things that mathematicians are known for, i.e. scientific notation, writing long numbers in a short format. That's all this is. It's a way to write the same thing in a shorter format. Because if you look at it, this x is going to be applied to the g, and it's going to be applied to the f the same way it would be written here. All right. So don't let this blow your mind when you see it. It's just a more succinct way to write these functions and these operations of functions. So let's jump into one. Let's do 24.5. All right, so if f of x equals the log of x, remember those, and g of x is equal to x squared plus 6, find, ooh, that looks wonky, g of f of x. All right, so this little notation right here, this little circle right here, it just means to put f of x into the g machine. So what that would be g of f of x would be equal to, we would take the x for this for f of x, and we would put it into the x in g. So that means the log of x squared plus 6. All right, so whichever function is second, that is the one you're putting into the first one, okay? Not the other way around. Don't get that twisted. The first one represents the function. The second one represents the substitution value of x. Okay, if that makes sense. First is the function or equation. The second one is the sub value. All right, that's the way that that works out. That, guess what? We don't have any values. We don't know what the log of x is. So that's all we can do. This is the answer to 24.5. And the reason we did that was so you could learn this right here. So you could see an illustration and learn how to put that together. So when you see that little circle, that's all that means. Use the equation from the first one and use the second one as the substitution value for x. All right? And we'll put that here, for x. So let's do 24.6 and see if we can go a little bit further. Let me clear this. All right, so if f of x is equal to x plus 2 and g of x is equal to x squared plus 3, find, oh, we've got 4. They've got 4 of these they want us to do. So, okay, that's cool. So A, they're giving us, this is the A option, f plus g of x. Oh, actually, it's not x. Sorry. It's 6. So the x is 6. B is going to be f minus g of 6. And C is going to be the product, so fg of 6. And then D is going to be f divided by g of 6. Okay? So let's do A. A is f plus g of 6. So there's 2 ways to find the sum of f of 6 and g of 6. And the fast way is to find f of 6 and g of 6 and add them together. So if f of x is x plus 2, then f of 6 is going to be 6 plus 2, and that's going to be 8. And g of 6 is going to be 6 times 6 is 36 plus 3, which is 39. So then that would be 47. All right, that would be the fastest way to find A. So that is equal to 37. So let's do B. So then the same thing for B. The fastest way is just to subtract G from F. So let's find that. So we already know that F of 6 is 8 and G of 6 is 39. So we don't even have to do any more math for that. That's going to be 8 minus 39, which is going to really hurt my brain. So that's going to be negative 31. Right? So this is going to equal negative 31 because we already did this math, so we don't have to do any more. All right, and then the fast way for this one would just be to multiply the two together. So that would be 8 times 39. So I'm going to stack it a different way just because I always like to put my multiple digits on top. That's 2, carry a 7, 24. That's going to be 31. So that's going to equal 312. This is not really hard, guys. This is pretty straightforward. And so then the same thing would be here. F divided by G. So we have 8 over 39. There's really nothing we can do with that. I mean, there's no factors of 39 that are in 8, so the answer is just 8 over 39. That's it. And guess what? That's all we have for lesson 24. I will see you in lesson 25.